webinar Nipayumani uncovering the simplicity of AI. I'm Rasha Kavindi, first year engineering undergraduate in chemical and process engineering at University of Moratuwa, and I am delighted to be your moderator for today's event. Today, we embark on an exciting journey to explore the world of artificial intelligence and discover how this powerful technology is simplifying our lives and reshaping industries. AI is no longer a concept of the future. It is already a part of our lives. From virtual assistants to recommendation systems, and it's only getting more pervasive. As Sasnaka Sansada, our aim is to provide you with valuable insights into AI's working principles and its practical applications and how you can harness its power in your own projects. And without further delay, let's welcome our esteemed keynote speaker, Mr. Sansada Ranavira. He is a proud graduate of University of Moratuwa in electronics and telecommunication engineering. Now, he is working as a software engineer in BPH 200 Private Limited, Singapore, and as a visiting lecturer at University of Moratuwa. He is a distinguished expert in the field of artificial intelligence with a wealth of experience. Let's welcome Mr. Sansada Ranavira.
First of all, good evening to you all, and thank you, Sasnaka Sansada Nipayumani group, for organizing me for this event. It is the good pleasure to share my experience and knowledge with you all on the field of AI. So today talk, actually we going to have some look into the...
We can see the screen, but it's a little bit lagging there.
I am only showing the first cover page, right? I think. Is it?
Yes, sir. All good. I think Nirasha has lagging.
Yeah. So I think you can see the screen, right?
Yes, sir. Yeah, we can see.
Yeah. Okay. So in this talk, actually, mainly what we're going to do is we need to have some overview of what is AI and see how it works and do in a simple way of it, because a lot of you guys are eager to know what is AI is and hoping to get into the field of AI and do something in AI. So first of all, before we dig down into the topics of EIOC, what is AI is. So first of all, just answer this very simple question: what is AI? So because AI simply stands for artificial intelligence. So can you I think I would like if you can, if it is a physical, I can ask this question and have some answers. But if you can unmute mic and speak what is AI, I think it would be great. So then we can have a very interactive session rather than I'm talking and you listening. So before going into much more complex thing, let's firstly get some idea about what is AI is, or what is AI stand for, or what is AI is doing, or what is the reason behind AI. So any idea if you have about AI, I think you are welcome to share. You can just unmute your mic and speak, and I will give you a couple of minutes and then I move forward, because it is always good to have some interaction session rather than having only a one-way session. Anyone? Seems like nobody want to talk. Okay, so I just give us some very simple example in AI. So AIO, in other words, artificial intelligence. It is I don't want to go for entire definition. I just give the definition by typing this very exactly similar question with ChatGPT. Again, it is part of AI. It is a kind of going through the world like a boom, or every people is trying to figure using AI and using ChatGPT, and it is kind of trending in the world now. So everybody using it. So basically, AI is a field of computer science, or field of techniques that people develop to learn from data, or in the very simple words, we can say it is AI is a field of computer science or software engineering, anything you can, whatever you call it. It is branch of science. Actually, it is emerged as an effort of our as human beings. We try to replicate ourselves or our skills inside computers, because as humans we also like to replicate ourselves, or we like to replicate our skills, or we like to automate our tasks using machines or computers. So actually AI is the field that evolved to overcome the challenges incorporated with that. Basically, most of the time we can say in the software engineering terms or computer science terms, AI is a set of algorithms or set of methods that we can use to learn some stuff using the data. It means in typical computer science, what we do is we give instruction to the computers what step by step what to do. But in artificial intelligence, with the emergence of artificial intelligence, people get the approach to guide the computers using the data. It means they don't explicitly give instruction to the computers. Instead, they let computers to learn their own way, giving some example to them. So also I highlight some sentence that is called like actually AI involves the development of algorithms and computer programs that can learn from data, make predictions, and improve performance over time. So that's the most important thing in AI. It means in AI, we don't need to give precise instruction to the computers because they can learn. It is actually we give computers the ability to learn their own. So now you may be wondering that how computers can learn, how can be done, or is computers or do computers have brain to learn those stuff? So let's see how it goes. So before that, we need to first understand that what are the okay. So what are the human-like behavior, or what is meant by human-like behavior? So let's take a very simple example. If you take a computer and you give this image, so very nice image of a lovely cat. I think most of the people love cats, or some are hating it, but everybody can understand this picture of a cat. But if you can give this image to a computer or input this image to a computer, and it can say this image contains a cat, it is actually a human-like behavior, because computers are not built to perform that task. Oh, it is actually because as people, it is a very straightforward thing. Once we see this image, we can say straightforwardly, this is a cat. But for computer, it is not a straightforward thing, or it is not its behavior. Computers are built to rely to operate on the digital data, or ones and zeros and electric signals, not on those pictures or audios by default. Of course, it can play audios or view images, but it cannot understand the context of those images or audios by default. So in artificial intelligence, we want our computers to learn what are actually inside those images, or what are actually inside our audios or our videos. So because that is where the part that humans are coming into the play. Because if you want to recognize some tree or some disease or some bacteria or something, you need a human expert. So we are trying to replace the skill or those behavior with a computer. Also some other example, let's say some voice commanding also. Let's say I'm delivering this talk and you can understand what I'm saying, and you can grasp the words at times, and you can understand the context that we are discussing. But computers cannot understand human language. Let's say we tell the computer to turn on or turn off, and it can understand that command and perform the exact same thing inside its system. So it is actually kind of voice controlling. I think we have Siri inside our, if you use the Apple phone, or you can have Google Assistant, or you can have Cortana in Windows. So many more voice assistants are out there. So these are the actually human-like behavior, because things are look trivial to the humans, but it's not trivial to the computers. But it is very important to automate these things with the computer, because we can replace a lot of human labor with this kind of stuff. Let's say you have some voice assistant, you can replace sometimes a receptionist or call assistant, because you can replace those things with the that computer that understand voice commands. Or ChatGPT, you can entirely replace a dictionary or a search engine, because you can ask your query and it will generate a response for you. So I think somebody has accidentally unmute their mics. So, okay. So in artificial intelligence, so we are trying to replicate this behavior to the computers. So, and you may say, is this useful or this pretty much easy? And it's actually, this is pretty much difficult. And then you see why in the very next slide. Because there's a difference between human world and machines world. Or in other words, how we see the world versus how machines see the world. Because if machines can see the world in the same way as us, there's no need to worry and we can straight away perform these stuff. Because let's say our computers are same organ as our human brain, or as a species, as a human being or intelligent living being, we only need to train it away like as we train some human beings. We need to teach some language to them and make them train to do those tasks. But machines are different. They operate in a whole different way and they are built upon whole different components. As an example, as humans, we see an image, but in machines, it is see an image. It is storing an image not as a visual object but as a mathematical object. It means if you each pixel, because these images are consist of pixels. If you take any of these images, it is comprising of collection of dots. Each of these dots consider three values, namely R, G, and B. These are the general values, or you can have any of the color encoding. For simplicity, I only go with RGB. So these RGB values indicates how many of red, how many of green, how many of blue contained in that pixel. It means each of these, every pixel stands for one single color. In other words, our image is consisting of dots representing different colors. Actually, these colors are indicating of any integers between 0 to 255. I think you can have 2 million or 2.6 million or 3 million colors inside the image using that approach. So basically, what is computer storing is these three numbers per pixel and as an array. So you can, if you store in an array, you can see in this direction you have three values, and this direction you can have the values correspond to its width of the image, and in this direction you have the values correspond to your height of the image. So in that case, as we see an image of this picture, but computer sees a cube of numbers with three dimensions. Two of them are equal to the dimension of your picture, and one of them being 3, or sometimes it can be 4 if you use any other color scale like CMYK. And also, if you take an audio inside the computer, it represents as a set of numbers, or we usually call it as a samples. It means we hear audio, but our computers store it like as a set of numbers. Or usually what it done is, firstly it is convert this audio to some sort of electrical signal, and then it is take some samples after some intervals or between some intervals, and then store those values as a sequence of numbers or array of numbers inside the computer represent that audio. Usually you will see when you listen to audio files, something they could have sample rate. This correspond to how many of these samples you store per second. So usually it is go up to 320 kilohertz or 128 kilobits per second. It is actually some sort of sample rate measure that we talk. But the only point is, no matter whether we input a computer to an image or audio, it is actually storing it as some set of numbers or some sort of mathematical object. Even though the text, it is same, because we have some sort of encoding like same. Let's say if you want to type the letter of A in ASCII scheme, computer sees as this is a number 97. So inside the computer, it can only operate on these numbers. More specifically, if you go into bit more depth than this, every one of these actually store as zeros and ones at the end of the day, because in the computer at the later stage, at the CPU or a GPU, it can only operate on zeros and ones. So then we need to develop algorithms. If we need to replicate this human behavior inside machines, we need to incorporate some algorithms or develop some algorithms that can read images or audios or text which are storing at these numbers and then operate in this representation to get what we are wanted. So more specifically, something like this. First, we take one very simple example to see how we can instruct computers to do something. Before taking to the human-like behavior, first we make computers to do something. Let's say we input some number x to our computer and we need to tell this number is even or odd as an output. So to do that, we can write a very simple computer program which take a number as an input, and if it is divide, when we divide it by 0, if it is remainder is 0, we would say this number is even. But if the remainder is 1 or it is not 0, we can say this number is odd. It means in our conventional programming, we can specifically say computer what to do. But the problem with, let's say this, your input is an image. So it is actually a cube of numbers. You have some width and you have some height and you have some 3 of these numbers per each color, and you have this kind of cube of numbers as an input. You want to tell if in this picture there is a cat or there is no cat. Basically, it means you need to tell once you give the image, there is a cat in this image or there is not a cat in this image. If you need to write some computer program like this, it is a very complex task because you cannot write a simple if condition or a for loop to recognize cat inside image using those programming languages or these basic programming concepts. So you need to some different or some creative approach to do that. This is the thing that we need to do. Let's say you give this cat image or your cube of numbers to a computer, and by observing these numbers, your computer would able to provide these two outputs. It means it need to provide either this is a cat if there is a cat inside this image, or this is not a cat. It means there is no cat in the image. So how are you going to do that? Typically in artificial intelligence, we're going to say, actually we're going to denote these inputs and output as x and y, typically to ease of representation. And in our artificial intelligence domain, we call something called model that will do the job for us. It means if we give this kind of image or cube of numbers to a computer program, some special computer program, it should able to tell this is the cat or not a cat. Typically, that special computer program, which is I denote here is M, we call the model. So that's the basic idea of artificial intelligence. That's the basic intuition. So it means it is clear that apart from conventional programming, we need something special, we need something different, we need something has more promising to do the job for us, to replicate human level kind of thing or human level skills inside a computer. We need something special or we need something different. Let's see how we can do that. Typically in machine learning or artificial intelligence, the basic building block in machine learning, or if you get started with, we are started learning it actually neural networks, because that's a typically building block of machine learning models, and you can extend to any of things, specifically in supervised machine learning techniques, not other stuff. I firstly explain on the supervised machine learning techniques because that's pretty much easy to understand, and it is actually the almost everywhere we use when we want to replicate human-like behavior. So in neural networks, we have something called neurons. These neurons have, you can see something like functions or something like some sort of machines or some sort of objects we can find in nature. Because neurons get named because they are exactly similar how our neurons work in our body, or how our neuron cells in our body is exactly similar, the idea behind those neurons. These neurons can have multiple inputs. So don't worry about these things. I will explain about this later, how this can be connected. So neuron is some sort of operation in machine learning network that can take multiple numbers as its input. So it will output something like, it will firstly, if you need to produce its output, it firstly take some weighted summation of these numbers. Something like this. It means it will multiply each of these numbers, some sort of a weight, and then add some, we call it a bias or some sort of real number or constant, and then it will give that resulting summation or resulting that number to something called the activation function. So that is actually a main thing behind the neural network or the neuron. So usually you have an activation function, and this is actually a typical activation function we use inside the machine learning model is a ReLU activation function. It means you give some sort of number and it will output that number if that number is greater than or equal to 0, or it will return 0 if that number is negative. So it's a very simple activating function. So it is very simple, right? Because it is not a pretty much hard thing. You have something called neuron. It will take some set of numbers as an input, and it will take some weighted summation and add some bias, and then it will output the value of some activative function of that resulting value. So in simple, you can simply denote it as this. Because these activation functions we use in neural networks, we could introduce some non-linearities. Because if we use without these activation functions, we can only have linear summations or linear relations. But if we use activating functions which are nonlinear, you can represent arbitrary complex mathematical relations between inputs and outputs. So I'm not going into much more mathematical details of these functions. So if you don't know what are the linear relations or what is the what are the nonlinear relations, what is the importance of this, so I think it is okay to now, it's okay for now to learn this neuron as some sort of operation or some sort of programming tool that we can have to give some sort of numbers as an input and give some output as I express in this. You can have a weighted summation and add some bias. Usually we call these W parameters as weights or parameters of a model. Usually we learn these parameters, and also this bias also it is a parameter. So we learn these parameters during training, some process called training. So I will explain how we do training. So basically this W's and B is the parameters that we need to learn if we need to express our model. So some people are requested to explain this part again. So it is something like this. In a basic way of doing, making some model or some tool to get some input as our images or cube of numbers and produce some output as we need to, let's say, recognize that there's a cat inside the image or not. We basically go with something called neural networks. There's a neural networks are based on the idea called the neurons. Neurons in machine learning context are some objects or tool that we can use to take input as some set of numbers. Let's say you take 3 numbers, let's say x1, x2, and x3, and you take input of this neuron, and it will output first. It will output a weighted summation of these numbers. As an example, in this case, it will represent first output w1 x1 plus w2 x2 plus w3 x3, and then you give that in output to some sort of something called activating function. Okay, so it is something like in our neurons also, it is the same phenomena, because in our neuron, if you do biology or something, our neuron can take multiple inputs from other neurons, and it can activate if it is only those value inside its value go past a certain value, because usually our neurons are communicating using electric signals or electric voltages. So that voltage go past some value, it will activate. So that's how it gets named, this activating function. So basically it is take some inputs, those are probably come from other neurons. I will say I will explain to you how this connected to each other, but for simplicity I will only consider here it's only a one neuron. So it will take multiple number of numerical values or numbers as an input, and it will take a weighted summation of those numbers and add some bias, and then it will use some activation function to introduce some sort of non-linearity to its output. So it's basically a some sort of like a basic mathematical operation or basic operation inside neural networks. So if you want to learn more in these things, because actually I highly encourage you to go into something called geometrical deep learning, where they explain how you can approximate any complex mathematical relation between input and output using collection of these neurons. So for today's talk, I just want to give you some sort of an introduction to the neurons and the neural networks. For that, actually, you can, if you feel difficulty to understand what is this exactly neurons are doing, it is only sufficient to just get to know about this, how it relate its input to its output. It means you take some set of numbers and just get some weighted summation and bias, and you will go through some activation function. In this case, if you don't know what is activation functions are, it is for now it is sufficient to assume that is a value activation function, which is output your result, or inside this value it will give the exact same value if this value is greater than 0, or if it will output 0 if this value were negative value. So it is a very simple. Let's say if you have some activation function like this, if you give the value of 5 to here, it will output 5. But if you give a value to this one, let's say -7 or something, it will output 0, because when the value gets negative, no matter what the value is, you will get output as 0. If you plot this, you will get something like this. Sigma x and x, it will something like this. In the here, it will equal to y equal x, and in negative region, it will equals y equals 0. So it is something like this if you plot this one. So in neural networks or in machine learning context, the basic building block, or the in supervised machine learning context, it's something like this. You interconnect many of these neurons each together. It means you have some input, or probably you can have some multiple inputs, and then you give each of these input to some set of neurons. And output of these neurons again connected to another set of neurons, and you can have a giant network of these neurons. So basically, these guys we usually called as layers of our neural network, or sometimes we called hidden layers. And this we called as an input layer, and this we called as output layer. So what will happen is, actually, you may be wondering how we're going to interconnect this and how we're going to program this. Don't worry, there are very much developed programming languages and programming libraries to do that. Right? I will show you how to program a simple neural network in a couple of more slides. But here, actually, this is something like you will take a neuron that, as I explained in the previous slide, and interconnect them with as it performs this a gigantic neural network. So it means like you have some set of neurons here taking some sort of input, and their output again serve as an input for another set of neurons, and so forth. So it is, once you connect the one, it will look like a very complex neural network like this. So now the problem is, how we're going to train, or how we're going to build a neural network to perform a task we want, or perform a task that we need to perform as we need it. To do that, you need three basic things. First, as obvious, you need a neural network, because if you need to train a neural network, or you need to use some knowledge to a neural network, first of all, you need to have a neural network. Then you need to have a data set. Also, you need to have a loss function, and you need to have an optimizer. So I will explain what of these four things are in a coming slide, because actually I explained what is a neural network is, but I will explain what is a data set, and what is the loss function, and what is an optimizer in terms of a supervised learning setting, because I will explain other type of neural networks at the end of this talk, but for simplicity, I will move forward with the supervised setting to simplicity. So first of all, see what are a data set. Let's say you need to learn this relation between these variable x and y. So then, if you consider the values I consider here as blue dots, let me change my color. So these blue dots, these can serve as a data set or some set of examples for our models to learn how the relation is look like. It means if our model need to approximate the relation between x and y as this red curve, or it is actually basically you see curve fitting, it is a very basic mathematical problem. It is actually very simple problem that we encounter. It is not a real world problem. It's very rarely that we need to find some relation between one real number and another real number as a variable. But for simplicity, I will move forward with this example. So these blue dots will serve as an example. You say, if our model, if I give 1 to the model, this will output, let's say, 5. If we'll output give 2 to the model, this will output, let's say, 6. This is the same way in our early childhood, let's say when we are in grade 5 or grade 6, when we are drawing a graph, we will plot firstly a set of points that we know what are the exact values are. Because you know, if you know 2 values, you can draw a straight line. But if you need to plot a many complex relation than that, like exactly this red line, you need to have many more values. Sometimes you cannot find a relation to go through all of these points, but what you can do is you can minimize the error, or you can approximate the relation between your examples that you give and the model prediction that can give. So in other words, data set is the set of knowledge that you want to inject your machine learning models. In our cat example, you need to provide some images that including cats and also no cats, because it needs to see the images both including cats and both including not including cat to distinguish between the images with cats and not cats. So data set is like performing this task or this use case inside machine learning models. Basically, you give some examples or you give some preliminary data model to learn. And second, when you have data set, you need to have some sort of a loss function, because when you have a model and it will giving up some predictions, you need to measure to how your prediction and actual value will deviate. Let's say, let's consider this value. This is actually some XY coordinate, and your prediction which lie in this red curve. And clearly there is a difference. And this difference, you can take it as a loss. Usually in this example, we can represent as in this function. It means you consider each and every sample and you take the gap between your prediction and the exact value that you predict, and you square it. Because you usually square it because we need to make that loss always positive. Otherwise, if you take just the separation, what will happen is, in these cases, your loss will become negative, and in this case, your loss will become positive. When you add them up, you will end up a 0 sometimes, because if you have, let's say, some is different as 5 and some has a difference of -5, when you add them up, it will result to 0. So it is wrong, because your loss is not 0. But when you square it, both of these 25, when you add them up, you get 50, and you have positive loss value, and your approximation is not correct or not deviant. So actually in our machine learning context, we call this as a MSE loss. So this is actually a measure how much our model's prediction is deviate from the ground truth or the exact same thing that we need to predict. Because this is loss function is really, really important, because we need to measure how well our model performs, or we need to know how well our model is fit or how well our model is learned. So this loss function also need to serve the function or serve the purpose of giving us some sort of a measure that we can approximate our model's performance. In this case, because if I take something like let's say I just take loss function as our model's prediction, it is not a good measure, because we do not know how well our model is performing. So when we choosing a loss function, our loss function should be an indicator of model's performance. Or let's say our loss is high, our model's performance should be bad. when our model performance is good, our loss function should give us a very small value. So that's the purpose of a loss function. After we take a loss function, we need to have an optimizer. Because if our loss function is good, we need to make it small. Because usually, if we take our loss function like this, our function will depend on weights or parameters of our model. Because as I previously mentioned, our model is having something like this and have some activation functions. So these are my parameters. So in our loss function, obviously, if we take this approximation, our parameters come into the picture here. So when we change these parameters, obviously our loss function is changing. So during training or during our building our model, what we're going to do is we're going to minimize our loss function by changing these parameters. Or in other words, we will find the optimal set of parameters that can result a minimum loss of our objective function or our machine learning model or an artificial intelligence model or deep learning model or whatever you call it. So here, the most popular algorithm or most heavily used algorithm is a gradient descent algorithm. The simple idea is you initiate your parameters to some set of parameters at start, or let's say when you start training, you will initialize your parameters randomly, and then you calculate your gradient of your loss function with respect to those parameters. Because if you learn calculus, you know that the gradient of a function is equivalent to a direction where your function is heavily increasing. Because the direction of your gradient is the direction that your function can get a highest increment when you're changing your variable. In gradient descent algorithm, what you do is you move opposite to the direction of your gradient. If you take this W to be one variable, and this is actually, let's say, your loss function, and you have only a one variable. So you know, if a one variable function, if your gradient is positive, if you move towards positive direction, your function is increasing. But your gradient is negative or your tangent is negative, if you move toward to left direction or in this direction, your function will decrease. So in this one variable case, in optimal case, we need to be here. So what we're going to do is, if let's say we start in a question like this. So once we calculate the tangent or gradient, we will get a positive value. But if we need to minimize this function, what we're going to do is we move towards negative direction of your variable, and it will result decreasing your function. So that's the basic idea of the gradient descent algorithm. So you start somewhere and you calculate the gradient and you move towards the opposite direction of your gradient. So if you learn multivariate calculus, you obviously see this will work if you have even 100 or 200 variables. So I'm not going into the pretty much deep of those mathematics here. I just want to explain we have some brief mathematics concept or what is the brief idea here. So you can explore some sort of self-study or some sort of thing, and then you can easily understand what is this gradient descent is. So if you go into some YouTube and search for some videos on gradient descent, you can easily understand what this really is. Typically in machine learning training, we call this value gamma is step size, or sometimes we call it learning rate. And this algorithm we called gradient descent. Of course, we don't use exactly gradient descent during our training. Sometimes we called stochastic gradient descent, or something we called mini-batch gradient descent, or sometimes we called something called ADAM. And there are a lot of optimizing algorithms available in our machine learning literature to do this optimization for us. The important thing is, to do this optimization, there is existing libraries that will allow to do this without knowing any of these mathematics. So if you need to just get start into machine learning, as a starter, you can try out those libraries by yourself without knowing this in-depth mathematics. But I encourage you to learn these mathematics, because then you know what is exactly going under the hood on these algorithms. Okay, So when training, because this time is limited, I just give you a brief idea of machine learning context, and then you can see how it goes. In training, usually we have something called training curve. Training curve is plot of the loss when we going through the iteration. Let's say you start your iterations 1, 2, 3, 4, 5, and so forth. If you're training your model correctly, your loss should decrease. But here you can see there's a two different losses. One is training loss, another is generalization loss. Because in typically, if we have some training data set, we typically divide it into two sets. One is we call training set, and one is we call our validation set or dev set. Typically, we train our machine learning models on this training set, and we evaluate our machine learning models on our dev set or validation set. Because if we only train on our training set, what will happen is our machine learning models or our deep learning or artificial intelligence models will learn training data very well. But when we take them to a real world, it will fail because it cannot generalize. Let's say you get 100% performance on our training model. This can achieve by simply by memorizing our training example one by one. But if you memorize your training examples one by one, what will happen is once you encounter new input, you cannot give a correct or reasonable output to that real world input if you memorize our training examples. Typically, we call this scenario is overfitting because you have pretty much low training loss, but you have pretty much high generalization loss. And also, there's something called underfitting. Let's say you will only train for a couple of iterations. You will only train your model for very small amount of time. In that case, what will happen is your model is learned very less. Let's say you stop training somewhere here. Then what will happen is you learn, but your loss is pretty much high, even at your training set. So it is not a good way to stop your training or stop really good way to train your models. The optimum way is somewhere like this. You plot your both training loss and your validation loss, and you choose a point where your validation loss or your training loss, or typically we call it generalization loss, start to increase. So this is actually a pretty good place to stop your loss, stop your training, because you can decrease your training loss, but in the meantime, you will start to increase your generalization loss. So typically, most of the time, you will have higher generalization loss than the training loss. This is why it is harder to train a model, because it is obvious, because you are during training, your model is only seeing this part of data, but this data is hidden from the model during training. So of course, your loss in the validation set going to be high. So this is intuition. So there's also typically what people do is they have a training set, and sometimes they have dev set or well set, and they have also a separate test set too. It means once you train your model like this, and before deployment or before give it to the client or before you go into the end application, again they test on some separate set called test set. It means because sometimes what we do is we observe something like this. Let's say our loss is too high to stop at this point. What we do is we tune some hyperparameters, we adjust our learning rate, or we change some configurations in our model, and then we train our model again on those configurations and see how this model performance look like. So if you perform multiple of these iterations, so you go back and forth, it means you train in your train set and you let in your dev set, and you go back and forth to reduce this gap. Then what will happen is your model can overfit your dev set as well, or your validation set as well. So then to avoid that, people often tend to use some set of some other set called test set to overcome those issues. So, and this, putting those all together, you can have very elegant and very easy to learn framework like Torch to implement this neural network. So basically, this is actually I implement a neural network here. I'm not going into much detail. I just want to show you a code to how much easy to implement this. And this is a neural network. I implement basically this is a forward function where we define if you give input X, how you should give your input output Y. So this is where actually, if your basic Python program, just you can write just as some set of Python method that you write. You take some input and you return some output. So it is actually, this is the thing that we run when you call give input to your model. So in here, I take some random data set using some numeric method. I'm not going to much detail, and I create my model here, and I take my optimizer here. It is pretty much easy. It only take one line to define the optimizer. You don't need to learn heavy mathematics, even though if you go to the PyTorch documentation, you can find this stuff. So, and then to training, you just have to run this very simple loop, and you can train your machine learning model. This is a very simple machine learning model, but even for the complex machine learning models, the training loop look exactly same. So it is not much different. And then you can train easily the machine learning model. So I highly encourage you to learn this machine learning framework PyTorch or TensorFlow, because it is pretty much easy. So I'm not going into much to line by line explain how we do this one. I include this slide to showcase how it is easy because you don't need to learn these mathematics to implement these neural networks, because these machine learning libraries doing exactly the most of the stuff for you. You just need to prefer their documentation and get to know how to do this stuff. So I trained the simple neural network to approximate some set of mathematical functions, and these are the results. So if you can see that one, the same machine learning model or the AI model would be it is able to approximate various kind of functions, because this is a simple sine function, and this is a sinc function, and this is a summation of some set of sine functions, and this is another set of sine functions, and so forth. So it is a function is arbitrary, but the same network, it is able to train to approximate this function with almost no error. Actually, in this neural network, if you calculate the parameters, I think it is calculated around, I think 150 parameters. So with this very less amount of parameters, you can learn different set of functions with ease. So I think it is pretty much easy to see how this machine learning is working. And the one important thing is, once you build the machine learning model, you need to learn how you need to give your output. Here, because in machine learning models, typically, I say you take input as some cube of numbers. But as an output, you cannot produce text. Because in machine learning models or in AI models, usually we work with something called tensors. Tensors is nothing but you can see some set of matrices or high dimensional mathematical objects. So in this case, you need to have some encoding to give your machine learning models to make it easier for them. So in this case, I say, if I take an image to the machine learning models, I will tell the machine learning models to output 1 if this image contains a cat, or 0 if this image not containing a cat. And to do that one, it's pretty much hard, because you cannot train exact machine learning model to output exactly 0 or 1. To do that one, actually we use something called sigmoid activation function. Because if you plug any real number Z here, it will give some output between 0 and 1. Because when Z is into negative infinity, this will give 0. When Z go to negative infinity, this will give 0. And when Z go to positive infinity, this will give 1. So there are other type of activation function as well to do the same task. I just show you to them. One thing is like the sigmoid activation function, as I show you, you can restrict any output to be in between 0 and 1. And there's another one called tanh. It is actually, you can restrict your output in between -1 and 1. And also there's something called softmax output activation function, where you can restrict any output vector of elements to numbers between 0 and 1. It means you have some values, let's say Z1, Z2, Z3, and so forth. You can restrict each of these values to a number between 0 and 1. And more important, if you add these all of these numbers, it will result 1. So basically, it will map any of these number of array to a probability distribution. Because if you add the probabilities, you will get 1. So actually, we will use this activation function in multi-class classification. So if you hear this for the first time, it is just sufficient to know that there's something called activation function that will allow us to encode our input as the way we need. So, okay. So I think I may going in, I think, relevantly fast. If you have any question, you can put it in the chat. Otherwise, I continue because there are few things that I need to cover in upcoming slides. And because I need to give you some overview, because it is pretty much hard to like cover all this stuff in, I think, an hour or two. And here, I just give you some tips to study. If you start to learn machine learning models, where you start to learn. So some common architectures are like some common ways that doing machine learning are convolutional neural networks. If you focus in some tasks on images, or you can focus on recurrent neural networks if you focusing on text or time series or audio data. So there are a lot of convolutional neural networks such as ResNet, and you can have EfficientNet for like classification. Also, you have some VGG nets for classification. Also, for segmentation, you can have YOLO, and there are a lot of YOLO versions out there. And also RNN models, you can have some sort of, let's say, typically you have, let's say, some sort of LSTM models. You can have GRUs, and most of things I think you can have in the sequence model as well. So there are a lot of things that you can learn. But the most important thing is, no matter what are the architecture is, the underlying operations of these neural networks, or all of these networks are same. They only consist some sort of weighted multiplications and adding biases and some activation functions. Those are the only operations consisting in these every of these neural networks. But the way they are performing is a bit different to neural network from application to application, but underlying operations are exactly similar. So also there are several types of machine learning techniques that you can explore if you need to build some solution using machine learning problems. One is you have supervised learning. Typically, let's say you have labeled data. It means you have data and you know what should be your output is. Let's say you have some set of images. For each image, you know there's a cat or there's no cat. So you know what should be your output in the beforehand. So then you can go for supervised learning for these types. It means you provide both, in your example dataset, you provide both your images and your labeled or your desired output. And also you can go for unsupervised learning when you have unlabeled data. Let's say you have some set of images and you need to cluster them into some different clusters. So then you don't know actually how many of clusters will be, or how should you cluster those images. So those kind of scenarios, you can go for unsupervised learning, because where your output is not available at the initial point. And also you can go for reinforcement learning, where you can use a reward function that guide your model during your training procedure. Let's say you need to train a model to control some sort of a human robot. And then you can define some reward function based on an output action to give it some sort of indication as we learn. Like, let's say when we are learning in our exams, our exam marks are performing as a reward function. Because our marks is high, we know that we are learning good. But our marks are low, we know that we need to focus on our learning is better. It's kind of a feedback we give to our model to give it a guidance to flow in the right direction during training. And also, we can use self-supervised learning, where we can use a limited number of training data to label a limited number of label data, or we can use some set of data that are labeled during the training. Let's say you need to generate some set of model to recognize faces. Let's say face recognition system, or you need to generate a model. Let's say you given two images of faces, you need to tell these images are similar or not. So in this case, actually, we can perform machine learning. We can train machine learning models without having labels. So it means we can give them just we usually call them a triplet loss, and we can use some examples that are similar images and not similar images, and we can give to the machine learning model, and it will learn to generate an embedding or something to differentiate that images that are similar or not. Usually we call it actually a encoder. So you can study on that. I'm not going into much deep onto that because I just want to give you some overview. And also, if you cannot afford to have many of your labeled images, and if you only have a small portion of data to begin with, you can go semi-supervised learning. It means you start with small portion of data in your data set in label, and then during training, you can add data to your labeled data set with the help of your model. So it is one other approach that if you have hearing this for the first time, you can just note down these terms, so you can just hear these terms and then you can start with. So I highly recommend you can start with this supervised learning, because it is pretty much easy to learn and it is pretty much easy to implement. And also these 4 terms for strategies also you can implement after you get fluent with supervised learning. So if you're newbie to the machine learning, you can always go with supervised learning to start your learning. And for this case, actually, you can play around with the MNSIT dataset to begin with, and you can use some sort of fully connected neural network, very basic neural network to begin with to explore how you can code a neural network. And then we go into the most important part of today's talk, how we gonna formulate a real world problem into a machine learning problem or AI problem. So there are 2 things that we can have in machine learning pipeline. So first we have our input, and then inside our computer we have our model, and our model we will produce some sort of output. So when we have first we have a real world problem, we need to understand what type of input we have, whether it's an image or it is a text or it is an audio. And then we need to identify a suitable representation. For if it is an image, it is already understood, and we have the cube of numbers like representation for image. For text, we something called we have embedding. For audio, we again have some sort of embedding. So we need to find a suitable representation to represent them with some sort in a numerical way to give to our model. And also we need to find out some potential patterns or outliers with help of our domain knowledge, because we need to identify, let's say our cat image example, we need to identify what are the different sort of cat images that we can have, what are the different outliers, so what are the camera effects in those images that we can have, so what are the different colors that we can have, whether the images are black and white or not. So those kind of things that we need to understand. And then in the model case, we need to understand what is the suitable model architecture, and we need to identify what are our computation capabilities that we can have, because we cannot build a machine learning model or AI model that cannot be run inside our infrastructure. And also we need to identify what should be our training parameters, or what should be our training methods, whether it is a supervised setting or it is a self-supervised, or it is unsupervised setting, or what should be our learning rate, what should be our weight decay, or there are many more hyperparameters that we need to do. And also we need to understand output case, we need to understand what should be our end result. And we need to also identify a suitable representation. As I previously explained, if let's say if our image contains a cat, we need to output 1, or there's no cat, we need to output 0. So we need to come up with some sort of numerical encoding of our output to our image, to our end result, to make our machine learning models work. And also, we need to identify a suitable loss function. So there are a lot of loss functions. Let's say we have binary cross entropy, loss of binary classification problem, such as this, when we output 0 and 1. Also, we can have cross entropy loss. Also, we can have MSC loss. I explained to you this earlier. Also, you can have something called focal loss if you deal with image segmentation. And also, you can have, there are many more losses. If you can have, also you can have L1 loss. There are many more losses that you can explain. Even you can write your own loss function to measure how much your exact output deviate from your predefined or your suitable output. Or but sometimes in unsupervised setting, you don't find a loss function because you cannot define, you don't know what should be your actual output is. But in supervised setting, you should define a loss function to begin training it. And then I will outline some key skills that you will be required in the job market or in your future competition in your jobs. To if you need to secure a job in the machine learning context or machine learning area, what should the key skills that you need to develop? First and obvious skill, you should proficiently in programming languages, in mostly in Python, and should be familiar with libraries such as Torch, TensorFlow, or Keras, and there are many more pipelines. But highly popular libraries are these two things: Torch and TensorFlow, and also there are some platform called Onyx. Because this is if you focus on machine learning deployment, you need to learn about Onyx. It is called Open Neural Network Exchange Model. So you need to be familiar with those as well. And then in programming environment, you need to familiar with Jupyter Labs, Jupyter Notebooks, because these are the most of the time you do R&D works if you choose to be as an R&D researcher in machine learning domain or AI domain. Also, you need to be familiar with programming environments such as VS Code, PyCharm, and etc. Also, you need to familiar with Anaconda environment as well, because in that way you can maintain different environments in your machine learning in your same system with this, because the Conda is a typical framework that we use for that purpose as well. And also, you need to be familiar with the deployment tools such as Docker, Kubernetes, and there are many more platforms. And also, you can have MLflow and other stuff. And also, you need to be familiar with mathematics, mostly on calculus, linear algebra, and optimization. Most people do not emphasize on this. They have said you don't need to learn mathematics to come into the machine learning, but you need to learn, because when you learn mathematics, you know what are the exact things inside those machine learning or AI models. So then you will be doing things with sufficient knowledge, in what is actually happening inside. Otherwise, you will do the things blindly. And also, you need to have some domain knowledge. Let's say you are learning, you are doing something with some health thing. Let's say you are something doing with medical diagnosis. So you need to learn have some medical aspect as well. So you need to learn about diseases and potential health aspects as well. And also, if you're doing something in other domain, let's say vehicle monitoring or something, you need to learn something in traffic monitoring system or that area as well. So depending on the domain you are working on, you need to have some sort of domain knowledge to apply AI or machine learning techniques into that domain. Because without having domain knowledge, you cannot implement a machine learning model with a sustainability, because you can implement machine learning model with blind without knowing anything, but it is not sustainable. And also, you need to learn about some sort of security practices, cryptography, hashing, and thing, because securing machine learning model is very emerging topic these days, because you need to secure your machine learning models from your customers, as well as you need to secure your customers' data as a machine learning model developer. So it is a very, very important thing if you learn, because if you learn this thing as a machine learning engineer, if you learn some security practices, I think it will be a great value as you into your career. And also if you need to have some sort of hardware knowledge, let's say process or memory architecture, if you need to work on embedded ML, because I have some experience when I work with my first employment at which some Silicon Valley company where they work on to implement machine learning model on customized hardware. So it is pretty much exciting and emerging area these days, because people are trying to develop customized hardware for run machine learning models. So if you need to go into that area, you need to have some sort of hardware knowledge as well. And also you need to learn some sort of technologies as well, such as AWS, Azure, and GCP and etc. So there are a lot of cloud technologies. So basically most of the people these days use AWS and Azure. So most of the time people use AWS. Actually, almost every place I worked on use AWS. GCP is actually the Google Cloud Platform. So it is one other place that people are working on. But I think if you learn AWS, it is pretty much easy to learn, and it is most popular cloud platform in these days. And the career paths that you can have in machine learning is you can be an empirical researcher, where you research on machine learning model architectures and performances. So you take existing available model and do minor modifications, and you research on their performances and see how well they work on domains or different applications. And also you can go into theoretical research, where you develop novel algorithm or you develop architectures or optimization algorithms to build models to suit different applications or efficient implementation of machine learning models. So there you implement machine learning models, and you will work with mostly theoretical and mathematical knowledge behind those machine learning techniques. And also you can become a MLOps engineer, where you mainly work with model versioning or implementing or deployment machine learning model. Because when R&D team or R&D engineers make a machine learning models, they need something to make it deployable or make it workable in a real environment. So MLOps engineers are the ones who are doing that. If you need to make if you are a person who like to make something work, you can certainly become MLOps engineer. And ML dev engineers are more or less similar to MLOps engineers, but they are mainly work on infrastructure management and source code management and pipeline setup. It means if you are someone who would like to manage a system or manage an entire infrastructure, and you need to manage something more like into the management way, or you are more like into some building stage, or you are more like into the planning, and you are like more into development. Usually we call the development space. You can certainly choose that path. It means you mostly work with you basically managing a project. You manage the source code, you manage the pipeline, and you manage infrastructure, and you basically take care of the maintenance of the entire pipeline. So it is kind of another job that you can have. But sometimes these terms are used interchangeably. But mainly you can have two career paths in your way. You can be a researcher or you can be an engineer. But in both ways, in engineers mostly work on implementing and developing the real world systems, and researchers where they research on different models and develop models that to develop to certain more efficient implementation in the real world. But more or less, researchers do engineering works as well sometimes, and also engineers do some research work as well. So it is a trade-off between where you work, so you cannot become only an engineer. Sometimes you have to do some research work as well. So depend on the use case, your own research, you can choose what you need to do. That's it from the machine learning stage. I think I spent around 1 and 10 minutes. I think I go really fast, but if you have any question, I think probably you can ask now, and you can I think I don't think you have I have questions via the chat. I think you can unmute your mic and ask. So if you have any questions, I think you can ask now. Anyone? I think it's one is asked, wouldn't it be a threat for the humankind in future? I think no, because I think this is a very unpopular opinion. Because I think machine learning is not at the stage that challenge humans, because it is not we are making machine to think. It is just we are developing some mathematical theories to learn something from the data. So it cannot be that for the human. The only thing is in future we can see some sort of a tool set that are available inside inside our in the world. In the future, we can have many more tools that will allow us to do our tasks pretty much more efficiently and easily. So then, if you learn how to use those tools, and then you can survive in the job market. So it will not be threat to our job market as well. But in the making of the weapons and other stuff, I think it is always a threat in the science, because it is with every technology you can have, because every technology you can use for the harm the people. Even for electricity, you can use it for power up your house, or you can use to kill some animal or some human. So it is based on how you use it, but I think it won't be a threat, because for any threat, I think you can have some security measures to do that. So you can ask question in single or English, so that one. So how about the market demand for ML engineers in Sri Lanka? So in most in Sri Lanka, you can have job opportunities in ML Ops and ML Dev most probably, but for R&D, there are some few, but to be honest, most of the time, even though they are advertising as R&D jobs, they are do something actually most of the time into ML Ops or ML Dev sometimes. Something we call data annotating or other stuff, because in Sri Lanka it is quite low. It is pretty much hard to find pretty much core machine learning jobs. Most of you can have some software engineering jobs, because in machine learning most of the time you have to learn. It is actually machine learning is another way of software engineering job. So you can have some sort of software engineering background to do that as well. So most of the time in Sri Lanka, you have machine learning jobs, but mostly you have to do software jobs, because there are very less. I see core machine learning or core research are going on in Sri Lankan industry, because they are even only in the universities. But in universities, what will happen is like the pay is very less, so you cannot expect a high pay. So is there any AI community in Sri Lanka where I can get experience as a beginner for AI? So unfortunately, I think there are not much good communities in AI, but there are a few, because I think there are a few hackathons and there are a few communities in, I think, especially in UCSC, and there are a few in I think University of Moratuwa in CSC, and also with IT and as well. I think there are a few YouTube channels and Facebook groups as well. But for if you want to learn theoretical machine learning and you need to learn mathematical theories behind it, I think it is like almost no community in Sri Lanka, so better to build one. So if you need to get experiencing as a beginner for AI, you can probably go to Coursera and their YouTube. There are many of tutorials, so you can start with the deep learning specialization and also the machine learning course by Andrew. So there are pretty much a good thing to start, and also there are some courses available on Google's Garage or something. I think there are some platforms that are available for everyone to learn some short courses on Google. I want to know about AI faculty in Moratuwa campus. I think you can, it is initiative done by University of Moratuwa, but if you want to learn much more detail, I think you can probably contact me via my WhatsApp mobile number. So I think organizing committee will share my number, or I will share in this chat, so you can contact me later. Because yeah, what is the best way behind AI course of UOM software engineering course? Can you define in Sinhala? Okay, so memang AI course එකක් ගැන කිව්වොත් ඇත්තටම ලංකාවේ university courses ගැන ගත්තොත් ඇත්තටම මම ගොඩක් තෘප්තිමත් නැහැ ලංකාවේ AI courses කියලා තියෙන මේවා සම්බන්ධව. මොකද ඇත්තටම ලංකාවේ ගොඩාක්ම theoretical පැත්තට සහ ඒ කියන්නේ core machine learning ගැන උගන්වනවා ගොඩක් අඩුයි. ඒ කියන්නේ ගොඩාක්ම ඉගෙනගන්න ඒකේ අර software engineering පැත්ත. ඒ කියන්නේ කොහොමද ඒවා torch වගේ මේ මොකක් හරි programming මේකක් පාවිච්චි කරලා machine learning model එකක් හදාගන්නේ කොහොමද එකක් create කරන එක ගොඩක් software engineering aspect එක තමයි ගොඩක් කතා කරන්නේ machine learning වල. හැබැයි theoretical aspect එක කතා වෙනවා ගොඩක් අඩුයි ලංකාව ඇතුලේ. හැබැයි මම හිතන්නේ මොරටුව electronic department එකේ මම හිතන්නේ පොඩ්ඩක් අගට වෙන්න පොඩි modules ටිකක් තියෙනවා ටිකක් හොඳට කරන. ඊට අමතරව CS department එකේ මම හිතන්නේ module එකක් හෝ දෙකක් තියෙනවා. නමුත් අනිත් universities වල ඇත්තටම මම කියන්න දන්නේ නැහැ මොන වගේ modules තියෙන්නේ කියලා. නමුත් courses wise ගත්තොත් අර ලංකාවේ AI වලට අර international standard එකේ course එකක් ඇත්තටම නැතිම තරම්. මොකද ලෝකෙවත් මම හිතන්නේ AI වලට තියෙන pure AI courses ගොඩක් අඩුයි. මොකද ඒක ටිකක් emerging field නිසා Coursera එකේ නම් මම හිතන්නේ ටිකක් තියෙනවා. මම හිතන්නේ deep learning AI වල වගේ ටිකක් courses ටිකක් තියෙනවා. ඊට අමතරව MIT open course එකක් කියලා part of the courses content access කරන්න පුළුවන්. නමුත් ලංකාවේ නම් ඇත්තටම ඔය සිංහලෙන් තියෙන මේ කියන්නේ තියෙන courses ගොඩක් ඒවා ඇත්තටම අර beginner කෙනෙක් විදිහට ගොඩක් හොඳයි. හැබැයි වාට in depth international level එකට ඉගෙන ගන්න ඕන නම් මම හිතන්නේ පොඩ්ඩක් ඊට වඩා පොඩ්ඩක් වාට ඉස්සරහට online if you talk about AI industry, if there is support, I think there are plenty of resources available online, but there's not much support actually in Sri Lanka. You cannot have funding to do research or not. So if you want to pursue research career, you have to go abroad. You cannot perform research in Sri Lanka. So that's obvious fact. But in Sri Lanka, there are a lot of good there are a few companies that are doing AI. So you can join off these companies, and there are a few hackathons, and you can get experience from them. So I think there are, because there are not specific support for come to the AI, but there are a lot of online communities and openly available resource for anyone in the world, so you can use that. So can you some useful website to learn programming languages? You can certainly go with Buggy tutorials. There are a lot of tutorials. I think I will put it on the chat. You can learn Google for Buggy tutorials. So it is you can learn any programming language in that channel. It is very I highly recommend the channel. The channel name is the New Boston. So even I learned programming languages from it. And more advantages the AI. So yeah, so there's an AI course, but there are a few pros and cons in that course. So I cannot talk in publicly. So you can probably contact me personally, so I can give you more detail about it. So I can tell that is, could you please explain the connection of data science and AI? They are more or less the same thing. So AI, data science, machine learning, deep learning, and data analysis. So more or less big data, all of are telling the same thing, because for me, actually, they are the basic thing is the same. There are just fancy terms that people are used to what you call to emphasize their importance, or like make them fancy. So they are not much different. They're basically the same. If you learn the fundamentals well, so you can do anything. It's just a matter of time. If you be the data engineer or AI engineer or ML engineer, sometimes a software engineer or ML of 20, sometimes more of you are doing the same thing. Okay, are there any website to learn AI? You can probably go with deeplearning.ai. So that's the best thing, best website I know. It's done by Andrew Nick, so one of the pioneers of I think Google Brain as well. So you can probably refer that website. Any questions? Hello. Anyone? Hello. Okay, so is that a problem? Also, we can write at the same. So if you need to contact me anytime, you can contact me via Facebook, LinkedIn, or I think both of my usernames are in those sites are Sadushan98. So you can just search by my name, Sadushan Ranavira, and anything you can Sadushan Ranavira or Sadushan Chamant Ranavira. So you can also in my YouTube channel, I think I recently started some video on machine learning. So where I explain this topic in more detail, and I think because if you to give some background on AI, I think it will require more than 3 to 4 hours to give some. It is very hard to give introduction to machine learning in a very short period of time. So today's talk, I hope to give you some sort of brief intuition of what is AI is, and what are the things that are in the AI, and what are the key points. And I just need to at least to show some sort of the terminology in the AI and some brief idea about AI, so then you can have some starting point of learning AI. So if you need more details, you can refer Coursera Deep Learning AI, and if you want to refer more singular content, I think you can refer my YouTube channel as well. So I think I will share my YouTube channel link as with my I think I can share my YouTube channel with you guys also. I will share with OC organizing committee, and they will share through the WhatsApp group as well, so you can direct it to. So yeah. Oh, they are asking me the next session. So I think yeah, we can. If you want the next session, I think we can discuss and have it one. I think this session. I think I probably feel that is going too fast. I think I also feel like that one. I think probably this actually the content is worth to have 2 to 3 sessions. But anyway, I have to deliver this in this way, in this brief way, because I need to give you some sort of information as this one, because to make it complete. So I think yeah, if that time is available and if there possibility, I think according to my schedule, I think we can arrange one more to send if it's possible. Okay, so yeah, that's it from my side. I think organizing committee. So I think over to you.
A heartfelt thank you to our esteemed keynote speaker, Mr. Sandushan Ranavira, for sharing your expertise and insights with us today. We have successfully completed today's event. Without the efforts and contribution of many people, this event would not be possible. Now, it is time to express gratitude to everyone who provided unending assistance to make this possible. I invite Sachita Disanayaka, Nipayumani project coordinator. He is an undergraduate in computer engineering at University of Jaffna. I invite Sachinta Disanayaka to offer the vote of thanks.
Am I audible?
Yes, you're audible.
Good evening, everyone. The organizing committee extended a heartfelt vote of thanks to Mr. Sandushan Ranavira, a software engineer and visiting lecturer at the University of Moratuwa, for his invaluable insights during the AI online webinar. Mr. Madhura Seneviratna, a chemistry undergraduate and Sasnaka Sansada profiling and cooperative affairs field head, also contributed to the event's success. The committee's tireless efforts and the active engagement of participants made the AI webinar an exceptional and memorable event. Thank you very much.
Thank you, Sachinta. With that, the event has come to a close. I want to express my gratitude to everyone who joined us today, including our speaker for the day. Keep innovating, keep learning, and together, let's shape a future empowered by the simplicity of AI. We appreciate your participation today, and we look forward to seeing you in our future webinars. Have a wonderful evening. Thank you very much.